Welcome, Pedro. You're a PhD student here at the Human-Computer Interaction Chair at Hasso-Plattner Institute. Can you tell us a little about your current thesis project?
Yeah, so my current, and actually I'm almost done with it, thesis project that I did here at the HPI for the last 6 years is about using sort of new types of interfaces that are closer to the human body. So I'm using a lot of interfaces that use a technique for medical rehabilitation called electrical muscle stimulation. By using electrical muscle stimulation, rather than your smartphone giving you feedback by, vibrating or something like that, it can actually make your muscles move. And so I got really curious about that, and together with Professor Patrick Bodish over the last 6 years, we started thinking, what could we do with that? And we found out a bunch of interesting things. For instance, one of the things we can do is make virtual reality way more immersive than it is now. Right now, if you try virtual reality, you put on these headsets, and you can see really beautiful 3D worlds, but you cannot touch them, you cannot feel them. But if a computer can move your muscles, it means the computer can create forces on your muscles. So let's say you're going to touch a virtual wall in that VR world, and suddenly the computer moves your muscles with a tiny, safe, electrical, medically compliant current, makes your muscles move automatically. It's not your own choice, but they just move, and suddenly you feel a force. You feel like there's actually a wall in there that stopped your hand in virtual reality. And so by using this, we're trying to ask questions of how much force can we produce in virtual reality? What kind of other things can we only do walls? Turns out we can also do simulations of weight, like feel like good gravity when you grab on a cube and you feel like weight. We can make you feel like wind is blowing you away by moving your muscles and just producing the sound of the wind blowing. And so we found a bunch of things that are really interesting once you start asking the question, what if the computer could move your muscles?
How did you come up with exactly this idea? Did it just pop into your mind at some point, or does it relate to prior projects you've been working on?
This was very new. Before I joined HPI, I was working on trying to create new types of touchscreens that use sound and microphones to detect really tiny vibrations. When you touch the touchscreen, you could know more of how the user is interacting with the touchscreen. But when I came here, a lot of excitement is going on in this lab all the time, and so I really wanted to find a new idea. And turns out I went to the doctor, and this technique, electrical muscle stimulation, is used at the doctor for rehabilitation. I was doing rehabilitation, the normal thing, the doctor sets up the machine for you and then says, this is going to move your muscles, it's going to be a therapy session for 30 minutes, I'll be right back. And then the doctor leaves the room and leaves you there with the machine. And turns out the doctor, not just a small mistake, put the machine calibrated a little bit too intense. And so my muscles, which normally would just sort of massage it, started to move kind of out of control. And I thought, this is really interesting. What is going on here? My muscles are moving due to this electrical current. What could we do with this if we would not connect this machine to just the hands of a doctor? We've connected to an interactive system with camera tracking and all that stuff, and we could create a fully interactive computer that touches the human and can move the human. So that's how it came about. It was a little random, but if you think about it, you kind of have to be in the particular mindset to then, when these things happen, you can see them and say oh, that's interesting. How can we use that for such and such?
Would you consider the work you're doing basic research, or are you planning to iterate on it to finally develop a product?
It's neither basic research nor product, because these ideas are a little far-fetched right now to go into product. I mean, me and Patrick get a lot of companies that want to do work with us because this could be used for VR to make VR more immersive, have physical forces, but it's not clear how are these devices going to calibrate themselves. How do you put the electrodes, and are the electrodes good for 10 days or for 100 days, and stuff like that is really important for product. So in that sense, it's a little preliminary prototypes to understand what are the potential of the technology, but it's also not basic research in the sense of neuroscience and neurophysiology of how the muscles move. I've recently started to collaborate with other people at FU Berlin University and also at UCL to try to understand more of, okay, basic research questions such as, if I move your muscles, how does your brain understand that? That is not you that is moving, but it's some external force that is magically moving your body. Do you know that you're not the agent anymore? That you're not liable and responsible for this motion? Which part of your brain actually triggers that? And that's more of a basic research question, but the research here at the HPI is more at the application level and at the research level in human-computer interaction.
What are your next steps and milestones? And will you continue working on the software once you're done with your thesis?
Yeah, that's a good question. I think I will do some more muscle stimulation things when I'm out of HPI. So I'm going to go now become an assistant professor at the University of Chicago in the next few months. And I think my group will do some EMS research that continues part of what happened here. But I think more importantly, I'll try to generalize the things that I found here and ask the question, were these things unique to muscle stimulation? Or can I do the same approaches, making things more realistic, talking directly to the body rather than just to indirectly through your eyesight and through vibrations, talking directly to the body? Can I do that with other modalities, not just the muscles? Can I do that with other parts of the human body? And how can I make interfaces more intimate and physical and connected to you throughout the day in a different way than we have right now? So that's kind of the questions I'll have for my next research group.
Thank you, Pedro. Good luck on your journey.
Thank you so much.